All right, we are in a new chapter, chapter 7, and chapter 7 deals with concepts with right triangles. To start, in section 7.1, we're going to look at being able to apply the Pythagorean theorem. Now, this, for the most part, should be review. We should be pretty familiar with the Pythagorean theorem. The Pythagorean theorem, by definition, which is shown here on the screen, it says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. So we know it commonly as a squared plus b squared equals c squared, where a and b are the legs and the value of c is the length of the hypotenuse. Just a quick review, we always know where the hypotenuse is because it's always the opposite side length to our 90-degree angle, and then our legs of our right triangle are always attached or touching that said right angle. Okay, so in your assignments, first off, they're going to try to ask you to find an unknown length. In this case, they want us to find the length of the hypotenuse. So what I would like you to do when you are solving these is to write out the Pythagorean theorem. The a squared plus b squared equals c squared. Now, I'd like you to do that each time you do these problems, so then you can identify which value is a, which value is b, and which value is c. So the first one I would like you to identify is which side length is in fact the hypotenuse. Like I said before, it's always going to be the value or the side length that is opposite the 90-degree angle. So this is going to be my value C. Now A and B can be interchanged. So 8 could be the value of A, or 8 could be the value of B. It doesn't matter. So it just was shown first here, so I'll call that A and I'll call that B. If you want to make the smaller value to be A, that's up to you. So I go over here and I just plug them in. So I'm going to say 8 squared plus 6 squared is going to equal x squared. And now, because of order of operation, we must take care of the exponents. So 8 squared is going to give me 64. 6 squared is going to give me 36. And then I'm just left with x squared on the right-hand side. So 64 plus 36 is 100. And to find the value of x, I must take the square root of both sides. The square root of 100 is 10, so x is 10. Okay. Looking at this example here, which is B, again, trying to identify where the hypotenuse is. Again, it's always the opposite, so this is going to be my value of C. So again, write it out. A squared plus B squared equals C squared. I'll call this my A value, and 21 is going to be my B value. So I go over here, 72 squared plus 21 squared equals x squared. So I just plug them into the formula. All right, now what we get to do is square all the numerical values. So 72 squared gives me 5,184. 21 squared gives me 441, and I have x squared. So 5,184 plus 441 gives me 5,625, which equals x squared. Final step, take the square root of both sides, and the square root of 5,625 is 75, so x is 75. Okay. When we look at the next page, these values here, they're asking to find one of the lengths of the legs. So they give you the hypotenuse. So the first thing I would, again, just like the other ones, I want you to find the value for C. And again, always the opposite of the 90-degree angle. So that's C. When I do the work here, I'm going to go here and say, okay, a squared plus b squared equals c squared. I have to identify those. So I go over here. I'm just going to call this A, and I'm going to call this B. So when I plug those into the formula, I get 3 squared plus x squared is equal to 5 squared. Now we get to square all the numerical values. 3 squared is 9 plus x squared, can't do anything with yet, and 5 squared is 25. Now we get to use our algebra skills. We subtract 9 from both sides. So now I got x squared equals 25 minus 9, which is 16. Take the square root of both sides. X is now going to equal the square root of 16, which is 4. Okay. For example B, again, my unknown length is right here, so I'm just going to call that x to start with. The hypotenuse, again, is the opposite of the 90-degree angle, so this is my value of C, which means that I can say this is A and this is B. Going through the process, writing out the definition, writing out the formula, a squared plus b squared equals c squared. So now I'm going to write this out as 6 squared plus x squared. Now with this 2 times the square root of 13 as my value of c, I'm going to write in parentheses, and I'll explain what that'll entail in a second. So I just wrote down the known values and unknown values and put them into the formula. Now I get to square them. The first one, the 6 squared, is fairly simple. 6 squared is 36 plus x squared. Now where it becomes a little bit more challenging is being able to identify with the 2 times the square root of 13 squared, okay? From things we looked at in previous sections of mathematics, whether it being practical algebra or intermediate algebra, the power to power rule states that this square is going to be squared by both the 2 and also the square root of 13. Okay, so 2 squared is going to give me 4, and it's going to be multiplied by the square root of 13 squared. The square root of 13 squared is just going to give me 13. That's just what happens when you take the square root and you square it. You just eliminate the square root and you get whatever's inside the inside the square root. So now what I get to do is I take 13 times 4, which gives me 52. So now I have 36 plus x squared equals 52. Let's solve for x. So subtract 36 from both sides. I get 52 minus 36, which gives me 16. Can't write the 16, I guess. So now I got x squared equals 16. Take the square root of both sides. X is going to equal 4. Okay? I don't know why I couldn't write it over there. Okay, the last thing that we're going to ask you to do is find the area of the triangle. So with these 2 examples, they are not right triangles. They could be, but they don't have the little square on one end, so we can't make a definitive decision whether they're right triangles or not, but we can still find the area of them. All right, if you guys remember, the area of any triangle is 1/2 base times by the height. Okay, so by looking at the side measurements of these 2 triangles, we have a certain type of triangle that is in relationship with their side lengths. Here I have triangle lengths of 18, 18, and 30. Anytime we have at least two equal side lengths in a triangle, those are isosceles triangles. Okay, so since we have isosceles triangles here and we have isosceles triangles here, we can find the area using the Pythagorean theorem. Okay, so what we have to do is we have to find the vertice that is touching both of the congruent sides. All right, remember vertices are these points right here. All right, so a triangle has three of them. But what we need to do is we need to find the vertice that touches both the values of 18, and that is right here. Okay, so now what I'm going to do is I'm going to make a line that is 90 degrees from the other side. Okay, so now what we can do is this. I want to find the length from here to here. And since it's an isosceles triangle, it cuts this triangle into two equal pieces. That means that the side length from this green marker is a value of 15. So from here to here is 15, and from here to here is also 15. So 15 plus 15 gives me the value of 30. So now I have this value of 15, I have this value of 18, but I don't know what this value of x is. The value for x is going to give me the height in order for us to find the area of the triangle. So we get to use the Pythagorean theorem. So I go over here and say a squared plus b squared equals c squared. The value of 18 is opposite the 90-degree angle, so that's going to be my value of c. So I'm going to say that that is c, and then these are interchangeable, so I'll call this a, I'll call this b. So when I rewrite this, it's going to be 15 squared plus x squared equals 18 squared. We take the numerical values and square them. 15 squared is 225 plus x squared equals 18 squared, which is 324. I take that 324 and I'm going to subtract it by 225. And I get a value of 99. So now I have x squared equals 99. I get to take the square root of 99, and it's not going to give me a nice clean integer, so it's approximately 9.95. So when I go back here, I can just write in 9.95. Now what I get to do is I can now use my triangle, area of a triangle formula in order to find the area for this specific triangle. So area is going to equal 1/2 times it by the base. The base is right here. So the base will be 30. And the height is what we just found using the Pythagorean theorem, which is 9.95 roughly. So 1/2 times it by 30 times it by 9.95 is going to give me a value roughly 149.25, and since there was no units, we'll just say square units. Okay, so if we look at the second triangle on our right here, we know that we already established that we found two sides that are equal. We have the 26 and the 26. So now we have to find the vertice that touches both of those side lengths, and it happens to be right here. So what we get to do is draw a 90-degree line from the opposite side. And now I need to find what is going to be this side length. And this side length is going to be exactly half of the whole side, which would give me a value of 10. We don't know what this is, and we have this 26 here. So in order to find the height, to find our area, we have to use the Pythagorean theorem. So again, we go a squared plus b squared equals c squared. 26 is my value for c because it's the opposite of the 90 degree. I'm going to call this a, and I'm going to call this b. So a is x, so it's x squared plus 10 squared is going to equal 26 squared. All right, x squared is just left as x squared plus 10 squared is 100, and 26 squared is going to be 676. Solve for x, so we subtract 100 to both sides, so I get x squared equals 575, or 576, I'm sorry. And finally, we take the square root of both sides. The square root of 576 gives me 24. So x is 24. So now we have all the information we need in order to find the area. So area equals 1/2 base times the height. It's going to be 1/2. The base is going to be right here, and that is 20. And then the height, which we found, is 24. So 1/2 times it by 20 times it by 24 equals 240, and it's going to be square units. Okay. Last thing we're going to look at is we're going to talk about Pythagorean triples. Definition of Pythagorean triples: it says you have any three positive integers a, b, and c, and if it in fact satisfies the Pythagorean theorem, then they become Pythagorean triples. So that means that any one of these values that are in these values could be in fact a right triangle with the side lengths a, b, and c. So if I look over here, I have 10, 24, and 26. When you are trying to test these, you're going to again use the Pythagorean theorem: a squared plus b squared equals c squared. And note that whenever you test these, the largest value is always going to be c. It is always going to be c. So looking at these values, call this a, we'll call this b, and we'll call this c. So in example A, the value for c is going to be 26. Always. It's the largest number amongst the three. If I look at B, it's going to be 13. And when I look at C, it's going to be 67. All right. Between A and B, it doesn't matter. So I can just go smallest, second smallest, stuff like that. Or I can go smallest, second smallest, smallest, second smallest. All right. That's the way you can identify whether they're Pythagorean triples or not. So now what we're going to do is plug it into this formula and see if it makes a true statement. If it makes a true statement, they are in fact Pythagorean triples. If they don't, then they're not. So I go over here and just write in 10 squared plus 24 squared to see if it equals 26 squared. And I get to square each one of these values. 10 squared is 100. And it's going to be plus 24 squared, which is 576, and 26 squared is 676. So the question you have to ask yourself, is 100 plus 576 equals 676? Yes, it is. It checks out. So yes, these sets of numbers do in fact make a Pythagorean triple. I look over here at example B. So I write in 5 squared plus 12 squared equals 13 squared. Square all the values. 5 squared is 25. 12 squared is 144. And 13 squared is 169. All right, so now we have to take 25 added to 144. Does it give us 169? Yes, it does. It does check out. So yes, these sets of values do in fact make a Pythagorean triple. Finally, C, we write in the values 32 squared plus 60 squared, and I need to see if it equals 67 squared. So 32 squared gives me 1024. Added to 60 squared gives us 3600. And it's going to be set equal to 67 squared, which gives me 4,489. So what I need to do is take 1024, add it to 3600, and when I add those together, I get 4,624, which does not equal 4,489. So no, these sets of values would not make a Pythagorean triple. And that is being able to apply the Pythagorean theorem. Hope this helps. Until next time.